Maybe if you could just give us a quick understanding of the difference between gut microbiome and phage DNA, or are they one the same? And what part of the microbiome, if you will, are phages today considered?
Yeah, for me, the definition of the microbiome is basically every microbial entity that is in the microbiome, if we're talking about the gut, for example. So that includes all the viruses. So when it comes to viruses, the situation gets quite complicated because viruses don't only consist of DNA, but there's viruses that are solely RNA, and then there's single-stranded and double-stranded, and there's segmented. So it's a very complicated situation. And there's also the lack of a universal marker gene, so you can't just do your PCR-based, amplicon-based analyses. So investigating the virome has always been more complicated than investigating other parts of the microbiome. But for me, they are an integral part of the microbiome. And then I specifically investigate bacteriophages. So these are the viruses that infect the bacteria. So then that kind of brings this extra layer of complexity to your investigations, because you have a system where you have a predator and a prey. And then you have an even more complex situation where you have bacteriophages that can integrate their DNA into the chromosome of the bacteria. And thereby they can actually, instead of killing it, they contribute to its health by providing additional gene content. So when it comes to investigating bacteriophages as part of the microbiome, for me, it's a matter of quality over quantity, as in we're looking at what is there, what are the different groups that are there, rather than are there a lot of them or are there not a lot of them, because having two different bacteriophages can have a huge impact on what's happening for human health.